As we wrap up this unit, let's cover a few more trigonometric identities that will help us solve more complex problems and have further applications in calculus and beyond. As with the other identities we've learned this unit, we'll use these new identities to evaluate and simplify trigonometric expressions. Before we get started, be sure that you have the blank reference sheet from the lesson notes in front of you and ready to go so you can fill in the identities as we learn them. Pause and do that now if you haven't already. Also, if you haven't completed the pre-video activity found in the lesson notes, pause and do that now. Ready? Let's get started. In the pre-video activity, you were asked to take two of the versions of the cosine of a double angle formula and rearrange them so that they were solved for the squared term. Let's see how you did. Starting with the identity cosine 2 theta equals 1 minus 2 sine squared theta, we can subtract 1 on both sides. Then divide by -2. This gives us the new identity sine squared theta equals 1 minus cosine 2 theta over 2. Similarly, we can rearrange cosine 2 theta equals 2 cosine squared theta minus 1 by adding 1 to both sides and then dividing by 2. Now we have the identity cosine squared theta equals cosine 2 theta plus 1 over 2. These identities are called power-reducing identities because they allow us to express even powers of trigonometric functions in terms of first powers. The power-reducing trigonometric identities are useful tools in trigonometry and calculus, particularly when dealing with functions involving higher powers of trigonometric terms, making integration, differentiation, and simplification of trigonometric expressions easier. Now take a moment to derive the power-reducing identity for tangent using the power-reducing identities we just discovered. Using a quotient identity, we can rewrite tangent squared theta as sine squared theta over cosine squared theta. Then we can substitute using the power-reducing identities for sine squared and cosine squared. After a small simplification, we get the identity tangent squared theta equals 1 minus cosine 2 theta over 1 plus cosine 2 theta. Now that we have the three common power-reducing identities, be sure to write them down on your reference sheet. Now let's use these identities to evaluate and simplify trigonometric expressions. In this first example, we want to evaluate cosine squared of pi over 12. Since this is in the form cosine squared theta, we could use the power-reducing identity to evaluate. We can rewrite cosine squared of pi over 12 using the power-reducing identity, where theta is pi over 12. 2 times pi over 12 turns into pi over 6, which we do know the cosine of. The cosine of pi over 6 is the square root of 3 over 2. And after simplifying, we get the result 2 plus root 3 over 4. Could we have solved this problem a different way? You may have noticed that we could rewrite cosine squared of pi over 12 as cosine of pi over 12 squared. While, again, we don't know the cosine of pi over 12, it is half of pi over 6, so we could use the cosine of a half angle identity. There's often more than one way to solve these types of problems. In this example, we want to rewrite the expression sine cubed x cosine squared x using powers no greater than 1. This method is often very useful when integrating in calculus because rewriting higher power terms into linear forms makes it easier to integrate directly. To start rewriting this particular expression, we will want to split sine cubed x into sine x and sine squared x so that we can apply the power-reducing identities. After some simplifying, we see that we end up with another squared term. Since we want to rewrite with powers no greater than 1, what should we do now? We can apply the power reduction identity for cosine again. Notice this time that instead of x, we have 2x. Therefore, when we apply the identity, we will have 4x instead of 2x. Now we can replace cosine squared of 2x with 1 plus cosine of 4x over 2 and simplify to 1/8 sine x times 1 minus cosine 4x. In our last example, we want to verify the identity tangent squared theta plus 1/2 secant squared theta equals 2 minus cosine 2 theta over 1 plus cosine 2 theta. Make sure your reference sheets are handy and try this one yourself. There are multiple ways to approach this problem, and one way to start is by using a reciprocal identity to rewrite secant squared theta as 1 over cosine squared theta. Now we can use the power-reducing identities for tangent and cosine to rewrite the left side with linear terms. Finally, we can do some simplifying and verify the identity. Great work! Today we covered the power-reducing identities, which you should have recorded on your reference sheet, and we used them to solve problems and simplify expressions. Be sure to keep your reference sheet handy as you complete the lesson activities and online practice, and as we continue learning more identities and applying them throughout this unit. See you next time!
Hey, hey.